To perform controlled experiments in the lab, we need to know the amount of each substance we are using. We do need to know the number of moles. But counting the number of molecules or atoms we use is just not possible. We can't even see them. We can determine the mass using a balance. You can use a balance to figure out mass. You can use a graduated cylinder to figure out volume. Therefore, there must be a relationship between the amount in moles and the mass of a substance. An atom is a very small entity. It's measured in atomic mass units. Atomic mass units. AMU for short. And the unit is U. The letter U. One atom of carbon-12 has a mass of 12.00 U. 1 mole of carbon-12, 6.02 times 10 to the 23rd atoms, has a mass of 12.00 grams. So when we talk atoms, we're talking one atom. The mass is in U's. When we're talking molar mass or moles, we've got a lot more atoms, and we're talking the units here and now, grams. For quantities, right? A mole is 6.02 times 10 to the 23rd. A whole lot of atoms, whereas one atom is just one atom. Okay, so the mass of 1 mole of substance is called the molar mass. It's called the molar mass. The symbol is a capital M. And the units are grams per mole. Water, we take 2 times the molar mass of hydrogen, and we add 1 oxygen to that. So what's the molar mass of hydrogen? Now?
18.2. O2.
What's the mass of 1 hydrogen?
Oh, I thought you meant altogether.
No.
Oh, okay. 1 hydrogen is 1.01.
Okay, thanks. 1.01 times 2. You're ahead of us. No. Oh, that's okay. 16.00. So 2.02 plus 16 is, now?
18.02.
18.02, and the units are grams per mole. So you take the number of each element, multiply it by its mass, add them all together. So carbon dioxide is 1 carbon and 2 oxygens. I don't know, it sounds like we're expecting a UFO to land any second. Okay, so 44.01 grams per mole. A lot more. All right, what I want you to do is the last one. 22.99. Chlorine, 35.45. Add them together. So that's the mass of a mole of sodium chloride. The amount of a substance, the mass and the molar mass are related to each other through an equation. So big M is molar mass, small n is moles, small m is mass. So, the formula is the number of moles is equal to the mass divided by the molar mass. If you need a magic triangle, small m over big M. Sometimes you're going to need some conversions too. You might be given information in kilograms, but because molar mass is in grams, you have to convert kilograms to grams. So there's 1,000 grams in 1 kilogram. There's 1,000 milligram in 1 gram. There's 1,000 millimole in 1 mole. So it just means like it's been divided by 1,000. So we're going to be using these. So you're expected to know these ratios, okay? They want us to find the amount, so they want us to find moles. If they want us to find moles, they must give us molar mass. This rarely happens. What they do give us is the chemical formula, so you actually have to calculate the molar mass and use it. So we've got 12 carbons, 22 hydrogens, and 11 oxygens. So this is 12 times 12.01, 22 times 1.01, and 11 times 16. So this would be 144.12. 22.22 and 176.00. So we're looking at 342.34 grams per mole. So now we know molar mass. We want to find moles. So N is equal to mass divided by molar mass. 40 grams divided by 342.34 grams per mole. So 0.11684 moles. Is this a big number or a small number? It's a fairly small number. How many significant digits can we have in our final answer? There's 3 here, and there's 5 here. Because we're dividing, you have to go with a smaller number, so 3. So we want to keep the 116. We're dropping the 8, so the 8 rounds. The 6 to a 7. To use our first ratio, we have to flip it. We are going to use 1 mole over 342.34 grams. I haven't changed the relationship. I've just changed the way it's written. To get rid of the grams on the bottom, the thing that we multiply it by has to have grams at the top. We only have one other number, and that's 40 grams. So if I multiply this by 40 grams, grams cancel. The units left are moles, so I know my math is going to be okay. You multiply by anything that's on the top, divide by anything that's on the bottom. So in your calculator, you would do 1 times 40, if you need to do that, and divide by 342.34. And that would give you your answer. No formula to remember. We have 4 millimoles of glucose. We don't have the molar mass of glucose. But trust me, it's 100.18 grams per mole. So, I know I've got 180.18 grams for every 1 mole. I've got a problem here. My value given is millimoles. But my unit for molar mass is 1 mole. So I'm going to have to convert. And I'm looking for the mass. So I'm looking for grams. So I've got 3 values. 4.0 moles, millimoles, my molar mass, and my ratio. My answer has to contain grams. So the first one of those 3 values I pick has to have grams in it, and it has to be on the top. So I have to pick my molar mass. So I'm going to take 180.18 gram over 1 mole. My next ratio has to include mole, because that's what's on the bottom down here. So whichever one you pick next has to have this in it. Use this. So this has moles in it. So I'm going to have to flip it. So now I've gotten rid of my first unit, but I've introduced another unit, millimole. So I need something that has millimoles in it. And I do my very first digit. So now millimoles cancel. So in my calculator, if I take 180.18, I multiply it by 4, and divide it by 1,000, I should get grams. So somebody with a calculator. To your starting numbers to see how many significant figures you can have. We can only have 2 for the 4.0. So here's our answer. 0.72 grams. Using formulas. We still can't use millimoles, so you have to convert. Still have to convert to moles. If you put that in your calculator is dumb. Your calculator does not know significant digit rules. So if you take 4.0 and divide by 1,000, it will tell you it's 0.004. You have to put the 0 in. There's two significant figures. So there's a 0 after the 4. So N is equal to mass divided by molar mass. So mass is moles times molar mass. Just rearrange the equation. So decimal 0040 times 180.18 grams for every 1 mole. Anybody want to tell me what the answer is? You get the exact same number, so it doesn't matter which way you choose to do it, you'll get the same answer. Once you get comfortable with dimensional analysis, it'll go really fast.